At present, the knowledge of the ocean surface at global and regional scales is easily determined from space. Satellite radar altimetry is a remote sensing technique to measure the ocean surface topography and its temporal variation, making this space technique a crucial tool for monitoring the global sea level change, one of the most concerning indicators of climate change. A nearly 30-year dataset from satellite altimetry is a fundamental source to derive critical variables that characterize the Earth climate and its variability. For instance, a global mean sea level rise of about 3 centimeters per decade has been observed globally by satellite altimetry. Changes in sea level, ocean circulation, winds and waves, sea ice, and river and lake levels derived from satellite altimetry are all fundamental inputs to the Copernicus Climate Change Service. In Portugal, the Faculty of Sciences of the University of Porto, or FCUP, has a research group dedicated to this remote sensing technique. Currently, this group consists of 6 people: 2 professors, Joana Fernandes and Clara Lázaro, 2 PhD students, Telmo Vieira and Pedro Aguiar, and 2 master students, Bernard Costa and Anderson Barcelos. The work conducted by this group has been developed in the scope of various projects supported mainly by the European Space Agency and EUMETSAT, such as the Climate Change Initiative, CCI, Sea Level. The accurate application of this technique depends directly on additional parameters, namely the wet tropospheric correction, or WTC, that accounts for the path delay in the altimeter observations due to the presence of water vapor in the troposphere. This correction is required to derive the sea surface levels from satellite altimetry observations. Therefore, the more accurate the WTC, the better the sea level dataset. The development of methodologies to compute an improved wet tropospheric correction has been the main topic of research at FCUP. One of the outputs of this work is the GNSS-derived path delay plus, or GPD plus algorithm, developed to calculate improved WTC corrections, particularly in coastal and inland water regions, for all satellite-based and operational altimetry missions. Presently, the GPD plus correction is already provided in some satellite altimetry products. At present, the focus of this research is the application of the GPD plus methodology to the most recent altimetric satellites, in particular the Copernicus Sentinel-3 and Sentinel-6 missions. Due to the importance of having an improved wet tropospheric correction to calculate the mean sea level time series, this research group is part of the Sentinel-3 and Sentinel-6 validation teams, the S3VT and S6VT. This group contributes to the improvement of the altimetric products derived from these missions, thus enabling a precise monitoring of the sea level rise from satellite altimetry. This becomes the answer of this space technique to the climate crisis more and more effective, since a better accuracy will foster a better monitoring of the climate changes and, consequently, promote the assessment of their impacts. Looking at our planet from space, namely in the scope of the Copernicus program, this Portuguese research team plays an important role in placing Portugal in a good position regarding climate science, Earth observation, and space technology.